All right, so while I was waving around all frantically trying to get your attention to pay really close attention to these truths, I stopped the video, and because I have no ability to pause the video and resume it, I have to start a second recording just based on the software that I have. So the Venn diagram illustrates two properties of complementary events. We're looking on page 258. Pay very close attention and memorize this. So if we have, look at this box that they drew. So they have event E. All right, this is E. Hi, E. This is E prime, or the complement of E. I'm going to use their vocab. The complement of E, E prime. The Venn diagram illustrates two properties of complementary events. First of all, they are mutually exclusive. It cannot simultaneously be raining and also not raining. I cannot be telling the truth and lying with the same statement. A statement is either true or it is a lie. It is not true, right? They are. It's a this or else not this. Someone is either Justin or not Justin, etc., etc., etc. So they are mutually exclusive. Also, the probability of E and the probability of E prime, the complement of E. I need to get rid of that old habit. I need to shake it off. The probability of something either being E or also not E, either one, it has to be 100%, right? Like, everything in the universe is either a potato or not a potato. No exceptions. So what is the probability of the object that I'm holding in my hand, the contents of my hand? What is the probability that either it's a potato or it's not a potato? The answer is 100%. It is either a potato or not a potato. 100%. So see those two bullet points? They're mutually exclusive. Number one, their probabilities add up to 1. The probabilities of both E and the complement of E add up to 1. Remember that. All right, let's do example 7. I hope I beat that dead horse sufficiently. Who would beat any horse, dead or alive? That's what I want to know. It's just wrong. But yet it just feels so right sometimes. Example 7, y'all. Look at it. They even draw mustaches on their 7s. I don't know if you noticed that before. The 7s on the font of my typing thing are that. Okay, so a basket contains 18 red flower petals and 12 white flower petals. You're apparently the flower girl at a wedding. Congratulations. A flower petal is randomly picked from the basket. Let W be the event of picking a white flower petal. Draw a Venn diagram to represent events W and also event W prime. Event not W, the complement of W. W and also not W. Give the meaning of event W and the complement of event W. So, in this example, I'm debating whether I want to draw it alongside the book or not. So in this example, they have this. Something is either a W or it's a complement of W. It's a not W. There are 12 different ways to get W, and there are 18 different ways to get not W, because there are, so W is the event of picking out a white flower petal. So when we explain, W is the event of picking a white flower petal. The complement of W is the event of picking a flower petal which is not white, which means it must be red, because the only non-white flower petals in this particular basket, I should do that differently. The only non-white flower petals in this particular basket of flower petals are red ones. So I want you to recognize that when we do a Venn diagram, these are possible events, possible outcomes of the event. This is not the actual. So if you pull, imagine throwing a dart at this picture that I drew. The dart might land here in the circle, and then it's like, aha, I picked a white flower petal. Or it might land here outside the circle but inside the rectangle, and you say, aha, I drew a red flower petal, a non-white flower petal. So these are possibilities. If we're on page 259 now, let's do B. It says find the probability of event W, and also find the probability of event W's complement, the complement of W. So we have how many total petals? We have 30 petals. So our denominator is 30. I forgot to do this, hang on. 259. So the probability of W, we have 30 flower petals and 12 of them are white. So we calculate this out. We get 2/5 or 40%. The probability of the complement of W equals, there should be equal signs right there. I'm running out of space, let me move it over. I tried to draw a percent and it decided to swipe left on my computer, which usually stops the recording, but it seems like it didn't do that this time, so I'm grateful for that. So the denominator is still 30. Any guesses what it's going to be? Without even using a calculator, if we know that this one's 40%, this one's got to be 80%. The reason being, or not 80%, sorry, 60%. 60%. The reason being, because if we add 40 plus 60, we know that any event and its complement need to add up to 100%. 100% dollars. Just kidding, not dollars, 100%. So one of those, if I pick a flower petal, it's either going to be red or white. There's a 100% chance that it's going to be red or white because picking a flower petal is red or white. Got it? Let's do GP number 7. Pause the video. Pause the video. I'm going to erase. Unpause when you are finished and confident or not confident and ready to see the answer. Good work. I hope you all are actually doing the guided practice. It just occurred to me that maybe someone would possibly not do the guided practice when I tell you to. If so, you are, I guess you're free to do that, but it would be a bad idea if you ask me. So you randomly choose a month from the 12 months of the year. Let A be the event of choosing a month that has the letter A in its name. We got to do some mapping out. I would probably have to use a calculator, not a calculator, a calendar to figure out, okay, which months are there? Hang on, January, February, March. Like, I'd have to really go through it. So we have, it says A, draw the Venn diagram. Here is what she looks like. Again, I hope you're watching me on double speed because I wouldn't want to watch myself on double speed. That would be amazing. So we have A inside the circle, and we have A prime outside the circle. So event A is, does it have a letter A in it? So we got January, February, we got March, we got April, we got May, we got June, July, June. I'm just going to do this. June, July, August has an A in it. Let's see, September does not. What's next? October does not. And then November, and then December also does not. That was easier than I expected. Okay. So what are the outcomes favorable to event A prime, A complement, the complement of A? It's all of these. The complement of A, these are the outcomes favorable to picking a random month that doesn't have an A in it. June, July, September, October, November, December. So C, find the probability of A and also the probability of A's complement. Well, 6 out of 12 are in either camp. So 50% and 50%, 6 out of 12. Turn the page. Moving on. Good work, everybody. We are on the page 260. We're getting there, guys. We're getting there. I know this one's kind of a long one. Example 8, solve a probability problem involving percents. 25% of the students in the school band play brass instruments. Among the brass players, 20% play the trombone. The band director randomly chooses a band member to play a solo. Draw a Venn diagram to represent the information. Guys, this one's going to get a little bit more tricky. A little bit more trickier because the reason we're multiplying percentages. I feel like Venn diagram in this case kind of sort of is taking the place of a bar model. I want to show this as a bar model too, just for those of you who like bar models. But first we're going to follow along with the solution. So it says draw a Venn diagram. So we have the total sample set of every student ever in this rectangle or at this particular school. How many of them play a brass instrument? About 1/4. So this is going to be about 1/4. So this is brass instrument. Brass. And of the brass instrument players, 20% play the trombone. That whole circle is contained inside of the other circle. Pretty neat, huh? So here are the trombonists. Trombonists. Aha. Everybody else doesn't play any brass instrument. Maybe they play, I don't know, the xylophone or something. Doesn't. So that's brass prime, or complement of brass, I guess you would say, is in the rectangle but outside this the circle. What is the probability that that a band member does not play the brass instrument? Stop and think about this for a second. If you just randomly pick a student, what is the probability that they do not play a brass instrument? Well, it's going to be this, right? This whole section. So if 25% do, that means 75% do not, right? Because they have to add up to 100%. What is the probability that a trombone player is selected? Now this gets a little bit more tricky. So now we're taking the trombone players and we're figuring out how they factor into the total. So we know that they factor into we know that they are 20% of the brass instruments. So if they are 20% of the brass players are trombonists, then what is the percentage of the greater whole? Now I kind of want to show a bar model. Now I'm gonna have a pause right here. So we have, no, we'll use this. We'll use the black, trusty old black. So here's my bar model. So 1/4 of the students at this school play brass instrument. That's these guys. Wiki, 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 wiki. Here are all the brass players, colored in with this color shown. Of those, 20%, which is 1/5, for those of you keeping score at home, not to scale. Let's try this again. I can do a better 1/5. Let's see. About here. Closer. I don't know. I'm leaving it. So 1/5 of those are trombonists. So what percentage of the trombonists are represented by everybody? Notice how I'm saying the word of. Remember what of means? It means multiply. So here we go. Look at the solution now on the bottom of page 260. Percentage of band members who play the trombone is 20% of 25%. So that's, we multiply. Of means multiply. So 0.2 times 0.25. That's, or also you can divide 25% by 5. 1/5 of 25% is 5%. Or it'll be 0.05. So this is 5% of this. Woo! 5%, just to be clear. Cool. I know that math got a little bit tricky. It kind of calls back to some of the earlier chapters that we did. Some of the really earlier chapters. So the probability, if you grab a random student in the halls of this particular school, you got a 5% chance that student is a trombonist, trombonizer, whatever the word is, I don't know. Trombone player, how's that? Yeah, it just lacks the flair of trombonist. Have to ask Mr. Manna if my verbiage is correct. I would, except I don't really care. I like trombonist. It sounds so great. I have a brother-in-law who's a trombonist for the Huskers. All right, guided practice. Pause the problem. Do guided practice number 8. Do it. Do it now. Guided practice 8. So what's the percentage? So it says copy the Venn diagram to represent the information. 40% of apples in an orchard are green and the rest of the apples are red. 5% of the red apples, 5% of the red apples are rotten. Rotten red apples. Ah, those apples look the same color to me. Copy the Venn diagram and represent the information below. So here's what they did. They took the whole scope. They made a circle for red, and they made not red, just be over here. So here's red, and here's red prime, complement of red. I keep using that word. Guys, that's just how I was trained. There's red and red prime. Oh, dee-doo-dee-doo-dee-doo-dee. And then 5% of these are nasty. Let me draw that bigger, or do this. Nasty. Nasty rotten apples. They're dead. There's some stink lines coming out of there. Stinky. So, what's the percentage of red apples? Well, 60. 60% are red, 40% are green. So it says to copy it, you're supposed to write those down. That's how you solve A. B, if you pick an apple at random for the orchard, what is the probability that you pick an apple that is red but not rotten? So you have to look at the not rotten apples. If 5% of the apples are rotten red, that means 95% are not rotten. And it wants to know, what's the odds of us picking out of this? What's the odds of us picking out of that lot? So 95% of 60%. We're just going to do that math straight across. So 95% are not rotten. So 0.95 times the 60% that are also red. Multiply those across. We get 0.57 or 57%. This is really good stuff, you guys. This is important work to doing much more advanced probabilities that will come in future grade levels. Because this grade's almost done. Guys, you're almost done with 7th grade. What? I know. Oh my gosh. I would call back to my own 7th grade, but it would make me cry. Let's do example 9. Example 9. Solve a probability involving a ratio. This is basically the same thing as what we've been doing, but ratios are given, they're just different. So out of 500 students, 156 study Spanish as a foreign language. Of those that study Spanish, 1 out of 6 of them are also studying French. Notice, a student could be studying French and yet not studying Spanish. They're outside of the scope of what we're talking about here. So we're not even going to draw their circle because we're not concerned with them right now. And some of them might be studying Latin. We're not concerned with them either. We're only concerned with those who are studying both Spanish and also French. So see how they did this? They did the 156 pointing to this circle. And then they do the not studying Spanish. So the whole thing is 500. That's our sample space. 500 students. 156 of them are studying Spanish, which means how many are studying not Spanish, not studying Spanish? Let's see, that would be 4, and then another 4, and then 3. 344 are not studying either. Not studying Spanish. They might be studying French, we don't know, we don't care. It doesn't concern us right now. So 1 out of 6 are doing Spanish and French. Those go-getters. Bless them. Espagnol et français. Let's continue this on the next page. We were already on page 261. I'm sorry. I forgot to update my page number up here. Hopefully no one was completely lost and confused, but they know what's going on. 262. Last page, y'all. What is the fraction of the students? So we have here, so 1/6 of 156. 1/6 times 156 over 1. basically it's 156 divided by 6, which equals 26 students. 26 students are in the language elites studying 2 different romantic languages, which are rooted in Latin. I feel like if you're studying Latin, you're studying the father of both of these languages, also the father of Italian, and possibly also, let's see what else. I don't know. Doesn't care. Doesn't matter right now. Moving on. So the fraction of the students studying both is 26 students over the total number of students. 500 students total. So therefore the fraction, it simplifies down to 13 over 250. This is the fraction of students that are studying both languages. 13 out of every 250 students, which is, so it says if you want to do, rewrite it as a decimal, it says, so C says if we pick one randomly out of the student body, what is the chance, odds, percentage odds, or decimal odds, excuse me, of us doing this? You just punch this into your calculator, guys. I'm not going to make you do long division. It's 0.0, I mean, I used to make you do long division, but now we're using calculators. Guys, gotta practice number 9, and then we're done. Do it. Pause video. Gotta practice number 9. There you go. Zoop. So gotta practice number 9. The Venn diagram, you should have this one, yeah, there's blue jelly beans and there's dark blue jelly beans. A subset of blue, or so I've been told. Among 200 jelly beans in a bag, 3 out of every 5 are blue. The jelly beans consist of light blue and dark blue at a ratio of 2 to 1. Ha 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 ha! Draw the Venn diagram. So your Venn diagram looks like this. So these are the dark blue. These are the blue. And over here we have just simply not blue. It's some other color that right now does not concern us. There are 200 jelly beans in the sample space. 120 of them are not blue, 80 of them are blue. What fraction of the jelly beans are light blue? Let's see. So the fraction is 2/5. I wonder why they did, guys, if you guys labeled this, if you guys did a subset of circles that are light blue, I would say that could be right too. You could do this little subset either as dark blue or light blue. That would be correct. In fact, I feel like light blue would make more sense because then they ask us about light blue in B and also C. So I don't know why we would do dark blue. Either way is fine. It doesn't matter. So I'm going to try to figure out why it's 2/5 for B. So what fraction of the jelly beans are light blue? The blue jelly beans consist of light blue ones and dark blue ones in the ratio of 2 to 1. I don't think it's 2/5. I gotta disagree with the book. I think it's 2/3. Oh no, of course. So I'm solving the question wrongly. I'm solving the wrong question. So yeah, it says what fraction of all of the jelly beans, what fraction of the total square is light blue? So we know that 2/3. Here we go. So 2/3. So if the ratio is 2 to 1, that means there are 2 light blue jelly beans for every 1 blue jelly bean. So that's 2/3 are light blue. 2/3 of 80 blue jelly beans. So 2/3 of the 80 blue jelly beans. So using the calculator matron, so that would be 2/3. You get a fraction. Why do they do fractions on us? Oh, here we go. I don't want to multiply by 80. I know that. Here's what we really want to do. Sorry guys, this one's hard for me even. I'm getting stuck. Here's what we want to do. So going back to forget this 80 business. Going back to it says 3 out of every 5 are blue. So 3/5 are blue. 3/5 of the jelly beans are blue. 2/3 of those, which means multiply, are light blue, which means 6, we cross multiply, or multiply straight across, so 6/15 jelly beans are light blue. 6/15 simplifies down to 2/5. That's the answer. Good night. It's been a long video. So if we pick randomly from that, what is the likelihood, what is the probability of the event of picking a light blue jelly bean? Give your answer as a decimal. 2/5 equals 0.4. That's all you got to do. Guys, that was it. That was almost an hour. Sorry, that was a long one. But like I said, hopefully you fasted forward me. Have a good time, and we'll see you next time. Goodbye.